Good morning to everyone. Myself P. Vanitha, working as assistant professor in the Department of Electronics and Electronics Engineering. Now we are going to discuss the electrodynamometer wattmeter. This instrument is used to measure electrical power. It works on the principle of interaction between magnetic fields. In this instrument, there are two important coils, the fixed coil and the moving coil. The fixed coil also called the current coil. The moving coil also called the potential or pressure coil. The current coil carries the load current. The potential coil is connected across the voltage supply. When current flows through these coils, magnetic fields are produced. Due to the interaction between these magnetic fields, a torque is produced. This torque is proportional to voltage, current, and the cosine of the phase angle between them. That means it measures true power. The moving coil is attached to the spindle and pointer. When the torque is produced, the pointer moves over the scale and indicates the power. Here the electrodynamometer wattmeter schematic diagram is shown in figure. Now let us understand a numerical problem based on wattmeter error. We are given current coil resistance is 0.1 ohms, pressure coil resistance is 6,500 ohms, voltage is 250 volts, and current is 12 amperes. In first case, unity power factor cos pi equals to 1. Actual power equal to V into I cos pi. That is 250 into 12 into 1. That is equal to 3000 watts. If the pressure coil is connected on the supply side, there is no power loss in the current coil. So power loss equal to I square into the R. That is 12 squared into 0.1. The answer is 14.4 watts. Next, percentage error. Percentage error is equal to 14.4 divided by 3000 into 100. That gives 0.48 percentage. That is 48 percentage. If the pressure coil is connected on the load side, power loss occurs in the pressure coil. Power loss equal to in the formula power loss equal to V squared divided by the RT. That is approximately 9.6 watts. Next, percentage error. Percentage error is 0.32 percentage. Now, second case, power factor is equal to 0.4. Actual power becomes 1200 watts. Here, the same losses produce higher percentage error because the actual power is lower. Percentage error becomes 1.2 percentage for supply side connection and 0.8% for load side connection. So we observe that at low power factor, percentage error increases. Now let us see the errors in electrodynamometer wattmeter. Pressure coil inductance, pressure coil capacitance, error due to mutual inductance effects, errors caused because of connections, eddy current errors, magnitude field errors, errors caused by vibration of moving system, temperature errors. Now let us move to the induction type wattmeter. This wattmeter, the construction diagram is shown in here. This wattmeter is used only for AC power measurement. It works based on the principle of mutual inductance. It has two electromagnets. One is series magnet, which carries load current, and second one is shunt magnet, which carries current proportional to voltage. Uh, Between these magnets, the aluminum disc is placed. When AC supply is given to this, the magnetic flux is produced. This changing flux induces the eddy currents in the aluminum disc. The interaction between flux and the eddy currents produces torque. This torque causes the disc to rotate, and the pointed indicates the power. In this instrument, the voltage coils are connected in series and wound on the shunt magnet. The current coils are wound on the series magnet to make the shunt flex lag the applied voltage by 90 degrees. Copper rings called shading bands are used. These shading bands helps in maintaining correct phase difference. For, uh, for controlling torque, spiral springs are used. For damping torque, a permanent magnet is used. The scale is almost uniform and covers around 300 degrees. This type of wattmeter can measure current up to 100 amperes. Now let us understand the difference between dynamometer type wattmeter and induction type wattmeter. In dynamometer type wattmeter, the current coil is divided into two parts. In induction type, both the current coils and the potential coil is divided into two parts. In dynamometer, potential coil is the moving part. In the induction type, aluminum disc is the moving part. A dynamometer can be used for both DC and AC applications. In induction type, can be used in only AC applications. In dynamometer, it has non-linear scale. In induction type, it has linear scale. In dynamometer type can be used in circuits with variable frequency. In induction type voltmeter cannot be used in the circuits with variable frequency. Now let us understand the difference between wattmeter and energy meter. A wattmeter measures instantaneous power. An energy meter measures total energy consumed over a period of time. A wattmeter gives readings in watts. The energy meter gives readings in kilowatt hours. Wattmeter is used for testing and laboratory purposes. The energy meter is used in homes and industries to measure electricity consumption. So simply remember, wattmeter measures power at a particular moment. Energy meter measures total energy consumed over time. So today we discussed electrodynamometer, wattmeter, error calculation in wattmeter, induction type wattmeter, comparison between wattmeter and energy meter. These instruments are very important in the electrical instruments. Thank you.